Welcome. PSM 201 Study Section 4. Sampling Techniques. Introduction. In sampling, information is sought about a group or population of subjects such as persons, households, hospitals, only through some of the persons or subjects. In this study section, some of the basic terms used in sampling will be discussed. Learning outcomes of study section 4. At the end of this section, students should be able to understand basic terms used in sampling, describe various methods of probability sampling with their respective advantages and disadvantages, describe various methods of non-probability sampling technique with their respective advantages and disadvantages. Sampling techniques. There are two basic ways of collecting information from the population. These are through complete enumeration, otherwise known as census, or through sampling. In census, the required information is collected from all the units, persons, household, clinic, etc., belonging to the population. However, studies in health and behavioral sciences are usually based on samples of the population. The rapid development of sample survey and body of theory that has been built up in order to provide a background for good sampling method was born out of the realization of some of the advantages of sampling. These advantages include low cost of conducting sample surveys in relation to census, speed of turning out results, increased precision and accuracy, as well as increased scope. When a sample is required to be drawn from a population, it is necessary to decide which method should be applied because the sample must be representative of the population. The various methods of sampling or sampling designs can be grouped under the heading random or probability sampling as well as non-probability sampling. Some basic sampling terminologies. Here are some important terms used in sampling procedure. A sample is a set of elements taken from a larger population. The sample is a subset of the population, which is the full set of elements or people from which you are sampling. A statistic is a numerical characteristic of a sample. A parameter is a numerical characteristic of a population. Target population. This is the aggregate of all the units about whom data is required and to which the findings of a study will apply. Study population. This is the population from which data are actually collected. Sampling error refers to the difference between the value of a sample statistic, such as sample mean, and the true value of the population parameter, such as the population mean. Note, some error is always present in sampling. The response rate is the percentage of people, units in the sample selected for the study who actually participate in the study. Sample size. Number of units to be included in a sample. Sampling fraction. This is the proportion of the total population constituted by a sample. For example, if the population size is 1,000 persons and the sample size is 250, the sampling fraction is 250 over 1,000. That is 1/4. A sampling frame is a list of all the units, people, that are in the population. An example of a sampling frame is the list of all registered students for an examination. Sampling units. This is the smallest unit involved in the selection process. Unit of inquiry. This is the unit about which information is required. Good or representative sample. This is a sample that adequately presents the characteristics of the population. It guarantees a reliable inference about population characteristics. It is also referred to as probability sample. Probability sampling methods. Probability or random sampling procedure usually produces representative samples. These techniques based on probability sampling ensure all elements, e.g., persons, households in the population have some chance of being included in the sample. The major types of probability sample are simple random sample, systematic sample, stratified random sample, cluster sample, multistage sample. Simple random sampling. This is the most basic type of random sampling technique. In this method, each item in the population has the same probability of being selected. In other words, it is an equal probability sampling method in that everyone in the sampling frame has an equal chance of being in the final sample. Simple random sampling is applicable when population is small, finite, and homogeneous. And of course, a sampling frame should be readily available. Without a clear sampling frame, it is impossible to take a simple random sample. The selection procedure can be by lottery, use of table of random numbers, or use of computer facilities. This is done by assigning a number to each unit in the sampling frame. Nowadays, researchers often use computer programs to randomly select their sample. Advantages: it is an equitable method of selection. Estimates based on this method are easy to compute. It gives the highest precision for estimates compared with other methods. Disadvantages: sampling frame may not exist or difficult to construct. Therefore, the method becomes impracticable. Subgroup of interest may not be adequately represented in the sample. It does not take into consideration the population structure. Systematic sampling. Systematic sampling relies on arranging the target population according to some ordering scheme and then selecting elements at regular intervals through the ordered list sampling frame. It involves a random start and then proceed with the selection of every constant element from then onwards. In this case, K is the population size or sample size. It is important that the starting point is not automatically the first in the list, but is instead randomly chosen from within the first to the kth element in the list. Example: a simple example would be to select every 10th name from the telephone directory and every 10th sample, also referred to as sampling, with a skip of 10. After the simple random selection of the first sample from the first to the 10th subject in the sampling frame, the above description could be stated as involving these three steps. First, determine the sampling interval, which is symbolized by K. It is the population size divided by the desired sample size. Second, randomly select a number between 1 and K and include that person in your sample. Third, include each kth element in your sample. For example, if K is 10 and your randomly selected number between 1 and 10 was 5, then you will select persons 5, 15, 25, 35, 45, etc. Advantages: sample easy to select. Suitable sampling frame can be identified easily. Sample evenly spread over entire reference population. Disadvantages: sample may be biased if hidden periodicity in population coincides with that of selection. Difficult to assess precision of estimates from one survey. Stratified random sampling. When population embraces a number of distinct categories, the frame can be organized into separate strata. Each stratum is then sampled as an independent subpopulation, out of which individual elements can be randomly selected. With this method, every unit in a stratum has equal chance of being selected. Meanwhile, using same sampling fraction for all strata ensures proportionate representation in the sample. That is, adequate representation of minority subgroups of interest can be ensured by stratification and varying sampling fraction between strata as required. To take a stratified random sample, follow the steps below. First, stratify your sampling frame into homogeneous group, e.g., divide it into the males and the females if you are using gender as a stratification variable. Second, take a random sample from each of these groups, that is, take a random sample of males and a random sample of females. Third, put these two sets of people together and you will have your final sample. On a final note, since each stratum is treated as an independent population, different sampling approaches can be applied to different stratum. It is also advisable that proportional allocation be applied in taking a stratified random sample. In proportional allocation, you make sure you subsamples, e.g., the samples of males and females are proportional to their size in the population. Example: assume that your population is 75% female and 25% male. Assume that you want a sample of size 100 and you want to stratify on the variable called gender. With proportional allocation, you will randomly select 75 females and 25 males from the gender populations. Advantages: increase in representativeness of the sample, increase in precision of estimates, applicability in heterogeneous population for reducing sampling error. Disadvantages: sampling frame of entire population has to be prepared separately for each stratum. When examining multiple criteria, stratifying variables may be related to some, but not to others, further complicating the design and potentially reducing the utility of the strata. In some cases, stratified sampling can potentially require a larger sample than would other methods. Cluster random sampling. In this type of sampling, it is required you randomly select clusters rather than randomly select individual type units, such as individual people, in the first stage of sampling. A cluster has more than one unit in it. The main features of this method of sampling include: population is divided into clusters of homogeneous units, usually based on geographical contiguity, and sampling units are grouped rather than individuals. In essence, it is useful in rural areas where there are no sampling frames. Some examples of clusters are schools, classrooms, departments, streets, and teams. This could be one-stage and two-stage cluster sampling. One-stage cluster sampling. This is a special case of multi-stage sampling whereby 100% sample is studied at the second stage. It requires random selection of a sample of clusters. Thereafter, including your final sample, all of the individual units that are in the randomly selected clusters. For example, if you randomly selected 15 classrooms, you will include all of the students in those 15 classrooms. Two-stage cluster sampling. This method entails two-stage sampling in which selection takes place only once. This is described as follows. In the first stage, you randomly select a sample of clusters, that is, just like you did in one-stage cluster sampling. In the second stage, you take a random sample of the elements in each of the clusters that is selected in the first stage. E.g., in stage 2, you might randomly select 10 students from each of the 15 classrooms you selected in one stage. More stages are possible in multi-stage sampling, which is discussed in more advanced books on sampling. Advantages: it cuts down on the cost of preparing a sampling frame. This can reduce travel and other administrative costs. Disadvantages: the precision is low because many first-stage units are excluded. Non-probability sampling techniques. Any sampling method where some elements of population have no chance of selection or where the probability of selection cannot be accurately determined is referred to as non-probability or non-random sampling method. In this method, you do not use probability concepts. It involves the selection of elements based on assumptions regarding the population of interest, which forms the criteria for selection. In other words, population elements are selected on the basis of their availability, e.g., because they volunteered or because of the researcher's personal judgment that they are representative. The consequence is that an unknown portion of the population is excluded, e.g., those who did not volunteer. Types of non-probability samples. Type of non-probability samples include convenience, quotas, and purposive samples. Convenience sampling. The procedure is just to contact sampling units that are convenient, such as a few friends or neighbors. It simply makes use of the people or subjects who are the most available or the most easily selected to be in your research study. It is the most common types of non-probability sample, not because such samples are necessarily easy to recruit, but because the researcher uses whatever individual that is available rather than selecting from the entire population. Because some members of the population have no chance of being sampled, the extent to which a convenient sample, regardless of its size, actually represents the entire population cannot be known. The method is, however, used for obtaining information quickly and inexpensively. Quota sampling. Quota sampling is a form of judgment sampling widely used to obtain specified quotas from which to build a sample roughly proportional to the population on a few demographic variables. That is, the technique sets quotas or numbers of kind of people you want and then use convenient sampling to meet those quotas. The population is first segmented into mutually exclusive subgroups, such as a stratified sampling. Thereafter, judgments used to select subjects or units from each segment based on a specified proportion. Examples: a set of quotas might be as follows: find 25 Yoruba males, 25 Hausa males, 25 Yoruba females, and 25 Hausa females. You use convenient sampling to find the people. The key is making sure you have the right number of people for each quota. Purposive or judgment sampling. With this sampling technique, the expert uses judgment to identify representative samples. That is, the researcher chooses the sample based on who they think would be appropriate for the study. This is used primarily when there is a limited number of people that have expertise in the area being researched. That is, specify the characteristics of your population of interest and locate individuals who match those characteristics. Judgment sampling is useful in situations where probability sampling is either feasible or prohibitively. Example: You might decide that you want to only include men who are aged 15 to 59 in your research study. You might try to find 50 students who meet your inclusion criteria and include them in your research study. Summary of Studies Section 4. In this study section, you have learned that there are two basic ways of collecting information from the population. These are through complete enumeration, otherwise known as census, or through sampling. Systematic sampling relies on arranging the target population according to some ordering scheme and then selecting elements at regular intervals through the ordered list sampling frame. In cluster random sampling, it is required you randomly select clusters rather than randomly select individual type units, such as individual people, in the first stage of sampling. Any sampling method where some elements of population have no chance of selection or where the probability of selection cannot be accurately determined is referred to as non-probability or non-random sampling method. The procedure is just to contact sampling units that are convenient, such as a few friends or neighbors. It simply makes use of the people or subjects who are the most available or the most easily selected to be in your research study. Now we've come to the end of Study Section 4. Thanks for listening.